Good morning from Mission Control Houston. It's Sunday, November 3rd, and I'm NASA's Anna Schneider. You're looking at a live view of the Dragon Freedom spacecraft as we await its departure from one docking port on the International Space Station to another, in what we refer to as a port relocation. This will free up the forward port for Dragon's upcoming 31st commercial resupply services mission to the International Space Station. We expect Dragon to push away from the space station with NASA astronauts Nick Hague, Suni Williams, and Butch Wilmore, and Roscosmos cosmonaut Aleksandr Gorbunov on board at approximately 5:35 a.m. Central, 6:35 a.m. Eastern. Today's port relocation is a joint operation between teams here in Mission Control Houston and the SpaceX Mission Control in Hawthorne, California. Teams here in the International Space Station Flight Control Room are currently being led by Flight Director Marcus Flores. And joining me from SpaceX in Hawthorne to walk you through everything today is Shiva. Hey, Shiva.
Hey, good morning, Anna, and good early morning here from the West Coast. My name is Shiva Bharadwaj. I'm a crew operations engineer here at SpaceX. Now, today's operation will be the fifth port relocation of a Dragon spacecraft, following those of Crew 1, Crew 2, Crew 6, and Crew 8. At this point, the crew is suited and seated in Dragon. Both the Dragon forward and the ISS docking port hatches have been closed, and we've conducted the vestibule leak check. So that's the volume in between the Dragon spacecraft and the ISS pressurized mating adapter. There are 4 seats configured in Dragon right now. Those are numbered from right to left when we're looking at the camera views in the seats. We don't have a view right now, but those are numbered from 1 to 4. So starting from in our perspective, from the rightmost seat, there's a shot of the crew. So we'll actually start from the leftmost seat is Butch Wilmore in seat 4. Next to him is Specialist Aleksandr Gorbunov in seat 3. Nick Hague is next to him in seat 2. He's the Dragon commander. And then in seat 1 on the far right of the screen is NASA astronaut Suni Williams. Now, we're coming up on the go, no go poll from both the joint NASA flight control team and the SpaceX mission control team. Once we get through that go, no go poll, Dragon will begin to push away from the station and perform the port relocation maneuver. That entire operation will last about 45 minutes. While Dragon is moving parking spots, the crew and the vehicle have undergone all of the same checkouts and preparations as though they were getting ready to come back to Earth. So in the unlikely event that we see some kind of condition that prevents us from docking back to station, the crew and vehicle are prepared to deorbit and return home safely, Anna.
Thanks, Shiva. And so as a reminder, Dragon will be moving from the forward-facing port of the space station's Harmony module and will then redock to the module's space-facing or zenith port. But before we go into greater detail on what all is involved in the port relocation process and some of those milestones that we're going to see, we'll go over a little bit of what already has happened this morning in preparation for today's operations. So about 4 hours ago, around 1 a.m. Central, the crew woke up aboard the International Space Station. And so in addition to the Crew-9 crew that you saw a minute ago, we have the rest of the Expedition 72 crew currently aboard the International Space Station, and they woke up and began preparing for today's activities. After that, around 2:30 this morning, the crew ingressed Dragon or entered the vehicle. So the 4 astronauts boarded Dragon for the port relocation maneuver. And then about an hour and a half ago, around 3:07 a.m. Central, the hatch on Dragon was closed. Shortly after the Dragon hatch was closed, the crew donned their SpaceX launch and re-entry suits, which will be worn by the crew throughout today's maneuver.
SpaceX on the big loop. Final reconfigurations for undock complete and nominal. Ground is go for undocking and port relocation. Targeting undock sequence start at 1130 Zulu. Confirm visors are down and crew ready for undock and departure at planned time.
SpaceX Freedom, we are visors down, ready for undock at 1130. Go for undock.
Station Houston, Big Loop, perform steps 2 through end in 1.602, Dragon port relocation monitoring.
This is Station 2. Copy. Block 2 in work, and undock sequence expected to start at 11 hours, 30 minutes.
Good read.
And you just heard some communication between the crew aboard the SpaceX Dragon vehicle as well as the crew on the International Space Station. And on the International Space Station, NASA astronaut Don Pettit will be monitoring today's operations from the station's cupola. So you heard those communications on what's referred to as the big loop. So that is a loop that is configured so the teams both in Mission Control here in Houston, as well as the Mission Control Center in Hawthorne, California, and the crew on the International Space Station and aboard Dragon can all talk on one loop, so everyone has awareness of everything that's going on throughout today's operations. You also heard that the teams have gone ahead and pulled go for today's port relocation, so we continue to be on track for today's maneuver. Again, we're targeting an undocking at 5:35 a.m. Central, 6:35 a.m. Eastern, with the undock command being issued about 5 minutes before then at 5:30 a.m. Central, 6:30 a.m. Eastern. So again, ahead of today's operations, after the Dragon hatch was closed, the crew donned their SpaceX suits. From then, once they finished suiting up, all 4 crew members performed leak checks on their suits, and we had 4 good leak checks. Following that, the APAS hatch on the station side was closed after NASA astronaut Don Pettit affixed the docking target to the outside of the APAS hatch, which created a space between Dragon and station known as the vestibule. Pettit then made his way out of the pressurized mating adapter, ensuring the forward hatch was closed, and again, he will be monitoring today's relocation maneuver from the space station's cupola. Once all hatches were closed, a ground command was sent to open valves on Dragon to begin depressurizing the vestibule.
Station Houston on the big loop. Want to get confirmation ISS crew is ready for Dragon undock.
Station copies.
And the voice that you were hearing call up to the crew from here in Mission Control Houston is known as the Capcom or capsule communicator, and you can see him on the center of your screen. Today's Capcom here in Mission Control Houston is Rob Hayhurst, and next to him on your screen is the flight director Marcus Flores. So again, recapping a little bit of what has led us to where we are now. Once all the hatches were closed between Dragon and the station, a ground command was sent to open valves on Dragon to begin depressurizing the vestibule, essentially venting the air from inside and bringing it down close to vacuum. They paused at approximately 5 pounds per square inch, or PSI, for a few minutes to allow temperatures inside the vestibule to stabilize before continuing the depress process. A few minutes before we came on air, the process to depressurize the vestibule was completed. Again, the vestibule is that space between Dragon and station hatches that will be exposed to the vacuum of space following undocking. Ground controllers command Dragon to begin the depress, opening a valve on the Dragon side to slowly remove the air from the vestibule, and once completed, the teams executed leak checks on Dragon and station to ensure both sides were airtight prior to undocking. We will reverse this process once Dragon is redocked, taking air from station and pressurizing the vestibule before hatches are open. Again, just a few minutes ago, we heard that the teams here in Mission Control Houston and the team at the SpaceX Mission Control in Hawthorne, California were both go for today's port relocation maneuver. With that, Shiva, why don't you walk us through what we expect for today's events?
Yeah, that sounds great, Anna. So coming up for today's events, the next major milestone will be at 5:30 Central Time or 6:30 Eastern Time. At that point, ground is going to send the undocking command. And Dragon, once it receives that command, will begin retracting its two umbilicals. Those provide power and data between the International Space Station and the Dragon spacecraft. Once those two umbilicals are disconnected and or pulled back into Dragon, Dragon will begin retracting the 12 hooks around the hard capture system that are currently holding it in place to station. And that whole process takes a few minutes. Now, at 5:35 Central Time, after those hooks have retracted, Dragon will fire its Draco thrusters. There'll be two short bursts of the thrusters to do what we call undock burns. And those basically break any sort of forces that are referred to as stiction between the Dragon spacecraft and the docking port and physically separate the Dragon spacecraft from the International Space Station. It'll slowly back away from the station. So that's the green line that's on the graphic on your screen. And then it'll activate its LiDAR system, its laser identification, detection, and ranging system. Light detection and ranging system. So we refer to those as its Dragon eyes, and it'll begin to track reflector devices on the space station. Around 5:43 Central Time, we're expecting Dragon to reach what's called the undock axis hold. So once we are seeing a good picture of the space station on our Dragon eyes, the ground will command Dragon into a hold that's about 60 meters away from the space station. Once everything is looking good, both on the spacecraft and once we feel confident that the Dragon eyes are looking healthy and able to successfully track the station, then Dragon will begin to move from to in front of the station and up towards the zenith port or the upward facing port. That's labeled as the transition maneuver here on the graphic in this kind of orange color. From there, the times are approximate and they'll depend on real-time performance of the thrusters to get to the next major milestone. Now, once Dragon begins its maneuver towards the space-facing port, the zenith port, that frees up the forward port where it has been residing since it docked for the upcoming commercial resupply mission, CRS-31, which is coming to the station. Now, around 5:54 Central Time, we're expecting that Dragon is going to reach the midpoint between the forward port and the zenith port along that transition maneuver. It takes about 15 minutes to get to that point. And you'll hear a check-in from the ground teams to the crew that we've reached the midpoint, and that just kind of updates their procedures to know that they are switching to the zenith port portion of approach to get back to the zenith axis. Around 6:03 Central Time, we're expecting Dragon will stop its hold maneuver because at that point it will have reached the docking axis hold. So the docking axis hold is where we are 60 meters above that port and preparing for final approach. That'll be the purple section on the screen here. Once we're on the zenith approach or zenith axis, then we're going to hold there before pressing into waypoint 2, and it becomes like a normal docking maneuver. And we are coming up on the undock command being sent right about now.
Freedom, SpaceX, undock sequence start.
Thanks, Jovan.
No copy.
And we just heard there confirmation that the undock command has been sent. So the umbilicals are now retracting. So with that undocking command being sent, there are two umbilicals that connect power and data between the two spacecraft. So those will detach, and then the 12 hooks that currently attach Dragon to the International Space Station will begin to retract, and there's two sets of 6 hooks.
Umbilical demate complete and nominal.
And we heard confirmation that the umbilicals have been demated. So next we'll stand by for those hooks to begin driving and detaching Dragon from the International Space Station. And the first set of 6 hooks is now traveling and beginning to detach Dragon from the International Space Station. Again, after both sets of 6 hooks, 12 in total, have retracted, Dragon will fire its Draco thrusters in 2 short bursts, known as undock burns, to break the stiction between Dragon and the docking port and physically separate the spacecraft from the International Space Station. Now, this process is a little different than some other undockings. So for Russian vehicles on the Russian docking adapter, there are actually springs that initiate that separation. But with the Dragon vehicle, we have those 2 short firings that help to break that stiction and separate it from the space station. And you're currently seeing a live view in the SpaceX Mission Control in Hawthorne, California, and the NASA Mission Control Center here in Houston, Texas. The International Space Station and Dragon are currently in an orbital nighttime, so the views are a little bit tricky currently. If we get views, we'll definitely show them, though, through today's operation. Again, about 2 minutes ago, that undocking command was sent to begin today's port relocation maneuver. The umbilicals have retracted.
Freedom SpaceX, first set of hooks open.
Freedom copies.
And now we have confirmation that that first set of 6 hooks have been opened, and the second set of hooks are now traveling and beginning to open. That will be the final set of hooks, and then we will have those undock burns to physically separate Dragon from the International Space Station and officially kick off today's maneuver. Again, those second set of hooks are continuing to drive open, and then we will be standing by for confirmation of physical separation.
Freedom SpaceX, all hooks open.
Copies. We see undock burn 1 and 2.
And undocking confirmed of the Dragon Freedom spacecraft from the International Space Station at 5:30 a.m. Central.
SpaceX Dragon separation confirmed.
Undocking confirmed of Dragon Freedom from the International Space Station at 5:35 a.m. Central, 6:35 a.m. Eastern, while the International Space Station and Dragon were flying approximately 260 statute miles over the southwest Pacific Ocean east of the Philippines. Again, after the hooks were opened, there were 2 short undock burns.
Relocate burn 0 complete.
Copies.
The first of those undock burns was just a really quick firing, about a second and a half long, followed by a 5-second burn after that. And then we just heard confirmation that the relocate burn was completed, and that was a 21-second burn. And so now Dragon is backing away and working to acquire its LiDAR tracking, which will be used by Dragon to autonomously execute the relocation maneuver. We expect the spacecraft to back straight away to about 60 meters. Again, if it goes past 60 meters, it will approach back to that distance before the maneuver to bring Dragon above the station begins. And there on your screen, you can see a view inside the Dragon spacecraft. And Nick Hague, NASA astronaut Nick Hague, is in the commander seat, or seat 3, in the center of your screen. And he...
Freedom SpaceX, Dragon Eye's looking good. Stand by for transition to a hold.
Freedom copies.
And Hague was flanked by Roscosmos cosmonaut Aleksandr Gorbunov in seat 2. And then Butch Wilmore was in seat 4 and Suni Williams in seat 1.
Command hold 1 while we evaluate Dragon Eye performance before we go to the relocate waypoint. You are go to raise visors.
Freedom copies all.
And you just heard some communication.
Houston, station on 2, block Charlie complete, thrusters enabled.
Houston copies, thrusters enabled.
And you just heard communication between the teams here in Mission Control Houston, as well as the SpaceX team in Hawthorne, California, between the crew on the International Space Station, as well as the Crew-9 Dragon vehicle. They are currently configuring that LiDAR system, which we heard earlier is also known as the Dragon Eye. The vehicle is currently about 80 meters away from the International Space Station, and they're holding while they configure everything and make sure all the systems on Dragon are good to begin today's maneuver and relocation. And currently on your screen, you can actually see a view of the International Space Station from the camera on Dragon. So that is the docking port where Dragon was just located a few minutes ago.
SpaceX ground has confirmed good relative navigation performance and will be commanding go to relocate shortly. This will target the 60-meter waypoint.
Copies, good run nav. Expecting, targeting the relocate point shortly.
And there you heard good confirmation of that LiDAR signal. Again, that stands for the light detection and ranging. This allows Dragon to begin tracking the space station along its maneuver path today. Since it's now acquired a good signal, the ground then commanded Dragon to hold at approximately 60 meters, and then it is now going to begin moving in front of the station to above it, and that will be what is known as the transition maneuver. Again, today's maneuver is from the forward-facing port to the space-facing port. This will free up the forward port for Dragon's upcoming 31st Commercial Resupply Services mission to the International Space Station. And we expect it to take about 15 minutes for Dragon to make the trip above the space station with a check-in at about halfway, which will be called the midpoint. Dragon will then hold once it reaches the docking axis, so that the axis directly above the port where it will be redocking today to prepare for final approach. And so once it's reached this docking axis, which means it's directly in front of its new destination, it'll hold there again for a few minutes before pressing into waypoint 2. The joint NASA and SpaceX flight control teams will then conduct a quick pull before approaching waypoint 2, which is just 20 meters away from the International Space Station. And following this brief hold and pull, the flight controllers in the SpaceX Mission Control in Hawthorne, California will once again command Dragon to begin its approach, flying it until it reaches waypoint 2. Once Dragon reaches about 20 meters away from its new docking port, it will hold for one final time for teams on the ground and the astronauts aboard Dragon to do a final check before docking. And during this hold, teams will ensure final alignment, checkouts of the spacecraft, confirm readiness for final approach, and check lighting conditions. And while there aren't any strict requirements to complete docking during a day or night pass, there is always the chance this hold could continue until the lighting conditions on the docking port are ideal. Once ready, Dragon will then begin its final approach, and the final approach process takes about 4 minutes, and during that period, you will hear a call out for CHOP, which stands for Crew Hands Off Point. This call occurs when the spacecraft is about 2 meters away from the docking port and means that any aborts need to be initiated by Dragon's flight computer after that point rather than by the crew. Dragon will then make initial contact with the space-facing port, and its soft capture system will retract to bring the spacecraft in closer for a hard capture, which is accomplished by deploying 12 hooks to firmly hold Dragon in place, and that process takes about 15 minutes before we have that hard capture and docking complete. For those of you who are just joining us, we had confirmation of undocking of the Dragon spacecraft for Crew-9 in its port relocation maneuver at 5:35 a.m. Central, 6:35 a.m. Eastern. Following that undocking, there was a relocate burn, which was a short 21-second burn, and Dragon backed away and acquired its LiDAR tracking system so that Dragon could automatically or autonomously execute today's relocation maneuver, and then the spacecraft backed straight away.
Freedom, SpaceX on the big loop. Ground will be commanding a relocate transfer to begin the axis transition. Soft capture ring deploy will begin in the second half of this transition when we go into relocate to axis. Stand by for transition to relocate to midpoint.
Copies all.
And again, shortly after the physical separation, there was a relocate burn, and then Dragon backed away to 60 meters away from the station. And then we just heard confirmation of the midpoint, and that Dragon is now going to begin its relocation above the space station. As we continue to work through all of these milestones for today's operation, let's go ahead and check back in with Shiva and SpaceX.
Cool. Thanks a bunch, Anna. Exciting stuff. We've actually got a view of the spacecraft from the ISS cameras. You can see the docking lights. That's kind of that white spot. And then on the either flanking side of the spacecraft, you can see the docking lights that indicate which side of Dragon is which. I believe that red is the left side of the Dragon vehicle, right is the green side of the vehicle, and it's slowly starting to make its way up towards the midpoint.
Station Houston, big loop. Monitor per step 6 of 1.602.
Houston Station, step 6 in work.
We are hearing a number of calls between the mission control teams and the Houston team. Sorry, both the mission control teams. So that's the SpaceX team and the Houston teams across the big loop. So as Anna was talking about earlier, the big loop communications are a pathway for all of the mission control teams, as well as the crew on board the space station and the Dragon spacecraft, to stay in synchronization with one another. So the call outs there to the ISS crew, telling them to continue monitoring Dragon's approach. That, of course, is part of what the mission control teams are doing. They are monitoring Dragon, ensuring that its systems are healthy as it conducts this maneuver towards the midway point now, which is the next major milestone. But the crew on board Dragon also have the ability to send commands to the spacecraft if need be. Dragon is a largely autonomous spacecraft, and so it can conduct the maneuver once given the authorization to do so by ground teams. It can conduct the maneuver pretty much by itself, but both the Dragon crew and the ISS crew have the ability to send commands to the spacecraft if something were to go wrong, and that's part of what the ISS crew are doing in monitoring now. They've got views of the mission control teams right now. So part of what's challenging about getting views of the spacecraft is we either need a specific type of network connection to the ISS. Sometimes you'll hear that referred to as the KU band. So that's our high rate data rate communication. Or we need ground station coverage, which it looks like we just picked up. So now we've got this great view to the interior of the Dragon spacecraft. On the left side of your screen is the commander, Nick Hague. On the right hand of your screen, mission specialist, Aleksandr Gorbunov. In front of them, you can see the procedures that they're working out of. So on that view, the previous view we had on each of their screens, they were looking at what's called the forward view on the displays. In the center, they had a copy of their procedures for the port relocation maneuver. And now we've got a view looking back at the forward port on the International Space Station as we're starting to tilt up and come over to the spacefaring port, or that's also called the zenith port of the International Space Station. So the forward views that right now the mission specialist on the right-hand side is manipulating are giving the crew some attitude views. So what is Dragon's rates? They can also show what thrusters are firing. It was actually pretty cool earlier when Commander Hague was acknowledging one of the core's calls. We could hear some of the pulses of the Draco thrusters firing. They get a pretty reasonable workout while we are performing this translation maneuver, because Dragon uses those Draco thrusters to both give it the energy so that it can transition towards the zenith docking port, but also they are keeping Dragon pointed towards the International Space Station, keeping those LiDAR sensors, the Dragon eyes, pointed at the space station. Dragon uses its Dragon eyes to maintain this distance to the International Space Station. So the Dragon eyes are pointing at specific retroreflectors. They're essentially reflective patches positioned at specific locations on the International Space Station. Dragon sends out a pulse of light, and that light is returned, and then it's able to figure out where it is relative to the International Space Station, and then use that in its relative navigation correctional maneuvers. So that's what, once it gets a relative navigation signal from those Dragon eyes, that's being fed into its flight computers, and then Dragon will adjust its positioning and attitude accordingly to keep those in view. On the center screen, you can see what look like two triangles, and then there's a little white dot in the middle of them. That little white dot is Dragon. There's a purple line there that shows what its trajectory would be if there was no additional correction. So if the thrusters were to stop firing, of course, the thrusters are continuing to fire to keep it on a tight circle here, transitioning to the zenith port. And then those two triangles actually represent the bounds that Dragon needs to stay in. So as we're approaching the space station, we want to stay within predefined boundaries. If Dragon were to get outside of those boundaries, then we have rules for both the ground team and the vehicle to do what's called a breakout maneuver. Of course, everything is looking pretty normal for today's operation. Just a nice little parking spot change.
Freedom, SpaceX on the big loop. Midpoint has been reached.
Yep, copies.
So with that call out, we have reached the midpoint. Now we are heading to the docking axis. We are in an orbital nighttime, so that's kind of why the ISS looks like you're looking at a dark camera. But it's still amazing that we have these views of the space station. Now we threw around a little bit of terminology there that we were previously on the undocking axis, heading to this midpoint, and then now headed to the docking axis. All that means is we were on the forward port of the International Space Station. The way to think about that is most of the time, the International Space Station is orbiting around the Earth. And if you were to think of it as an airplane that's flying, the front of that airplane is the forward-facing port. And so that was the undock axis because that's where we undocked from. And now we are approaching the docking axis. And so you can see that on your screen. It looks like a black circle in the image that we're looking at right now on the top of the station. And so we refer to the zenith port here as the space-facing port. So again, going back to the analogy of If it was an airplane flying forward, if you were to imagine looking up, that would be the zenith direction. And in the International Space Station's case, that is the direction that points away from planet Earth and points up towards the stars. So Dragon is approaching from that axis. And part of the reason for that is for some of the objectives of the CRS-31 mission. The cargo resupply 31 mission requires it to go to the forward port, and there are a limited number of docking ports on the International Space Station that the Dragon spacecraft can dock to. So we're freeing up the forward port here so the 31st resupply mission can come to the station, and just putting the Dragon Crew-9 Freedom capsule on the zenith port. A little summary of what to expect coming next. We are expecting to reach the docking axis, so that would be the zenith axis, in just about 5 or 6 minutes from now. Once we get onto that axis, Dragon will command into a hold. That'll be about 60 meters away from the zenith port, and it'll be flying in formation with the International Space Station just above that location. In the meantime, flight controllers are going to be assessing whether Dragon is continuing to look healthy. And essentially, we've done this once before when Crew-9 reached the station. There's a set of rules and verifications that we go through both for the Dragon spacecraft and on the International Space Station side. That's what the flight control teams are working on in the mission control centers. And they're evaluating whether Dragon and the ISS are safe for the approach operation. So once teams have reviewed their flight rules, that's actually in work at the moment. Teams are getting ahead on that. Then they will give a go, no go to approach waypoint 2. Waypoint 2 is 20 meters away from the station. The closer proximity is actually a little bit easier on the thrusters and the propellant loads, and that's kind of our last opportunity to do a final check-in, make sure both Dragon and space station systems are healthy before doing the final approach. So once teams pull go for final approach and docking, as Anna had mentioned earlier, operators will send the command to the Dragon spacecraft. It'll begin its approach operation. And then during that period, as we get closer and closer to station, there are cutoff points where we don't want to send commands to the vehicle. We actually want to trust it to do the right action if it needs to prevent its maneuver.
Freedom SpaceX on the big loop, soft capture ring extension complete.
And so those points are referred to as the ground hands-off point and the crew hands-off point, or CHOP. And then, actually pretty good timing here, we heard the call out for the soft capture ring extension. So once we get past the crew hands-off point, we'll hear a couple of call outs from the crew of their relative distance to the International Space Station. They'll call out the range during that period. And then Dragon will hopefully soft capture a soft contact using that soft capture system onto the zenith docking port. Now, it's called the soft capture system because there's a series of dampers in that system. It helps get rid of any of the vibration and relative motion caused by the two spacecraft. It looks like a very slow, controlled maneuver, but of course, both spacecraft are orbiting around the Earth, and that means they're going at about 17,000 miles an hour around the planet. So the reason it looks so controlled is because their relative velocities to each other are pretty small. But there is still a little bit of relative motion there, so the soft capture system will damp out those relative motions And then we will retract the soft capture system, bringing the hard capture system into contact with the docking port. We'll secure the hard capture hooks. And then after we secure the hard capture hooks, we'll connect the umbilicals and repressurize that vestibule, and we'll be in the same configuration we were in before this whole maneuver, just on a different docking port. So if you're just joining us, we're actually coming up on the docking axis. So coming up on the approach to the space-facing port on the International Space Station. You're looking at a view of the Dragon spacecraft from ISS cameras. I know it kind of looks like a white blob, but that's just because of the exposure settings on the camera, which actually allows us to get some cool views of the thrusters firing as it gets towards the docking axis here. On board, we've got 3 NASA astronauts and 1 Roscosmos astronauts in their spacecraft, doing a port relocation maneuver that undocked from the space station on time earlier today. The next major milestone here should be a commanded hold at the 60-meter mark on the zenith axis, and then ground teams performing their go, no-go for approach to waypoint 2. Great views of the spacecraft and those thruster firings. You can't normally see the thrusters if we were just looking at it without kind of this overexposed view.
Freedom SpaceX, we've arrived at the second 60-meter hold point and Dragon is configured for docking. Confirm crew readiness for approach 1, and we're about to have a teacher's handover.
So crew are going through their final checks coming up for the operation. They'll be reviewing their procedures. That's actually what you see here. Commander Hague is scrolling through his procedure, making sure that he is familiar with the upcoming operations and steps, and then he'll give a call back to the core here shortly.
And Freedom SpaceX on the big loop. Repeating the call, we'll look for crew readiness for approach 1.
Freedom copies. Crew's ready for approach 1.
So with that call from Commander Hague, ground teams are going to be sending the command to continue with approach 1.
And SpaceX copies, Dragon.
We have just entered into an orbital daytime. So that's part of the reason why the space station looks significantly brighter at the moment. At the speeds that we're traveling around the Earth, the orbital daytime and nighttime happens significantly sooner than in a 24-hour day-night cycle here on the ground. And so in that view earlier, we had some great shots of the zenith port that the crew are going to be approaching. Now we're back on board the capsule, seeing a view on the displays. Crew look like they're comfortable, waiting for the approach maneuver. Now in this shot on the lower portion, so what would be the bottom of the screen is the forward port. That's the pressurized mating adapter. So Dragon was previously connected there. That's where the 31st Cargo Resupply mission is going to head to. And then the black circle in kind of the dead center of the screen is the zenith port. It's a little hard to tell from this view, but in the center of that, there is actually what is referred to as the docking target or a standoff. We saw some views of that on the forward port as Dragon was undocking and pushing away from station. That target has reflectors on it, and that's part of what Dragon uses to align itself as it's approaching station so that it comes in aligned both in the right orientation in pitch and yaw for a successful soft capture. And so as we get closer on the approach, we're likely to get some camera feeds, at least assuming the coverage is with us as far as the data connections, but we are likely to get some camera feeds that show us that docking standoff target as we get back towards the hatches on the ISS side. And it looks like the orbital sunrise is also starting to backlight planet Earth behind us. So that's what we're looking at. And again, that's why we called the zenith port the space-facing port, because the other side is the Earth-facing port, or rather the Earth-facing view. So part of what's happening here is the ground teams are performing configurations, both on the International Space Station side for approach and
Freedom SpaceX on the big loop. We're still waiting for our final goes to continue approach. But for your awareness, we are going to be planning a brief hold at waypoint 2 for Dragon Eye evaluations. So when we get to waypoint 2, we are going to expect a hold for just a couple minutes.
Freedom copies are waiting on the goes to proceed and expect to hold at waypoint 2.
Now that call is a good example of what operational communication looks like. The view that we had there was of the SpaceX core. So he is that view right there. That's Arthur Burial. He is the counterpart to NASA's Capcom. And so provided communication on the big loop to the crew of here's what's happening. Here's when we expect to do our next maneuver. By the way, there's something happening at waypoint 2. We're going to do a hold there for the evaluation. And then the crew executing great communication as well, echoing back those calls to confirm that they have understood the information. That's pretty common in operational communication because words can get dropped as you're communicating between the spacecraft and the ground teams. And so echoing back those calls ensures that everyone is on the same page and no information was lost in the process.
Freedom SpaceX ground is go for continued approach and will be commanding resume to approach to waypoint 2.
Copies were go for continued approach.
And so with the call there, ground has configured approach for waypoint 2.
Houston, big loop approach is resuming to waypoint 2. Monitor per step 3 in 1.102. That's Dragon approach and retreat monitoring.
And with that, we are on our way.
Monitor picking up in step 3, block Delta.
Great.
Anna, exciting stuff. We're back on our way to an approach operation towards the zenith port.
Yeah, thanks, Shiva, and thanks for walking us through the last 20 minutes or so during today's port relocation maneuver. Again, we just heard confirmation that we are go to resume approach to waypoint 2. And so once Dragon reaches that 20-meter point, it will hold one final time for teams on the ground and the astronauts aboard Dragon to do a final check before docking. Again, during this hold, teams will ensure final alignment, checkouts of the spacecraft, confirm readiness for final approach, and check lighting conditions. And while there aren't strict requirements to complete docking during a day or night pass, there's always the chance this hold could continue until the lighting conditions on the docking port are ideal. Just a moment ago, you saw a view from Dragon looking at the International Space Station, as they are currently in one of those day passes. Again, we go through orbital day and night times about every 90 minutes as the space station orbits around the Earth. So Dragon will reach that waypoint 2 in just a few moments. We should hear that confirmation, and we'll hear that they're standing by for that hold. And then once ready, Dragon will begin its final approach, and that final approach process takes about 4 minutes. And during that period, we will hear the call out for CHOP, which stands for Crew Hands-Off Point. And this call occurs when the spacecraft is about 2 meters away from the docking port, and means that any aborts need to be initiated by Dragon's flight computer after that, rather than by the crew. Dragon is currently about 23 meters away from the International Space Station. Again, that waypoint 2 is at about 20 meters away, so just approaching that waypoint 2, just a couple meters away. And there on your screen, you see a live view of that space-facing port that Dragon is making its way to, and that will be its final parking spot or docking port today to make room for the 31st cargo resupply mission. And we're currently in a brief but expected handover period between satellites. And so that's the tracking and data relay satellite system that provides our video views from the International Space Station. But currently on your screen, you can see a live view inside the SpaceX Mission Control and NASA Mission Control here in Houston, and those joint teams are monitoring today's operations. So the NASA Mission Control team is responsible for all of the activities aboard the International Space Station, and the SpaceX Mission Control is monitoring Dragon and all of its systems. And Dragon has now reached that 20-meter mark for waypoint 2, so it's currently holding there as teams do their final checkouts, final alignment to make sure everything is good to resume for final approach for today's redocking to the zenith or space-facing port. And as Dragon holds at that 20-meter waypoint 2, the teams here in Mission Control Houston, as well as the SpaceX teams in Hawthorne, California, are currently conducting the go, no-go poll for final approach.
Station Houston, Big Loop, please confirm that you have reviewed steps 5 and 6 and you are go for docking.
Station is go for docking.
And you heard some conversations between the Capcom or capsule communicator here in Mission Control Houston and NASA astronaut Don Pettit, currently aboard the International Space Station. Pettit has been monitoring today's operations from the station's cupola, and the Capcom serves as the voice link between teams here in Mission Control Houston and the space station crew aboard the International Space Station. And currently aboard the International Space Station, we have the Expedition 72 crew. So in addition to the Crew-9 crew currently aboard Dragon doing their port relocation maneuver, comprised of NASA astronaut Nick Hague, Butch Wilmore, and Suni Williams, as well as Roscosmos cosmonaut Aleksandr Gorbunov, we have Roscosmos cosmonauts Alexei Ovchinin and Yvonne Wagner, as well as NASA astronaut Don Pettit, who you just heard some words from a few minutes ago. And so those 7 crew members comprise the Expedition 72 crew currently aboard the International Space Station. And Expedition 72 began on September 23rd of this year and will end in the spring of next year once the crews depart on their respective vehicles. For those of you who are just joining us, we are going through Crew-9's port relocation maneuver from the forward-facing port to the space-facing or zenith port on the Harmony module of the International Space Station. This will clear up that forward port for the SpaceX's 31st cargo resupply services mission. Today's maneuver began at 5:35 a.m. Central, 6:35 a.m. Eastern, when Dragon undocked from the forward-facing port and began today's maneuver. It backed away to about 60 meters and held there for a few moments before beginning its relocation above the station. And now we are currently holding at about 20 meters away from its new port, its new destination, which will be the space-facing port on the Harmony module. And we're just holding to ensure that everything is good on Dragon, everything is good on the International Space Station, and all teams are ready for the final approach to conclude today's port relocation.
On the Big Loop, Dragon Eye checkouts are complete. Things are looking pretty good. I'd like you to confirm crew is ready for final approach and visors are down. At this time, ground is go for approach 2.
Freedom copies all, visors are down, crews go for docking.
Copy, crew is go. Ground will be commanding approach shortly.
And there.
Houston station on 2 for Dragon approach.
Good day, Don.
Yes, for procedure 1.102, it ends at step 4. Where is step? Oh, I just found step 5 and 6. Disregard.
Houston copies. Station Houston Big Loop, Dragon is on final approach and is go for docking. You can monitor per steps 5 and 6 in 1.102.
Station copies.
And we just heard a bit of communication between the teams on the ground, as well as the astronauts aboard Dragon in the International Space Station. So all teams on the ground have pulled go to begin final approach, and the crew aboard Dragon and station also confirmed that they are ready to begin this approach. So Dragon has now left its hold at waypoint 2 and is beginning that final approach. So that process will take about 4 minutes to complete. About 3 minutes into that, we will hear a call out for CHOP, which stands for crew hands-off point. So this occurs when the spacecraft is about 2 meters away from the docking port and means that any aborts will need to be initiated by Dragon's flight computer after that rather than by the crew. And then just a few moments after that, we will be standing by for initial contact and capture, which will then be followed by several different events to have a hard dock or hard mate of Dragon to its new port on the space-facing port of the International Space Station's Harmony module. Again, it left the waypoint 2 hold, which is at about 20 meters away from the International Space Station, and is continuing to approach in. Right now, Dragon is about 13 meters away from the International Space Station and closing in on its target.
Freedom 10 meters.
Copy 10.
And Dragon is now less than 10 meters away from the International Space Station, so in about 8 meters we will hear that call out for CHOP, which is the crew hands-off point, and then we will stand by for contact and capture. After initial contact with the space-facing port, its soft capture ring system on Dragon will retract to bring the spacecraft in closer for a hard capture, which will be accomplished by deploying 12 hooks. Again, 2 sets of 6 hooks to firmly hold Dragon in place. And that whole process will take about 15 minutes from the initial contact until we have the hard capture and docking complete.
Freedom 5 meters.
SpaceX copies 5.
And just a minute ago on your screen, you could actually see the docking target, which is that crosshair target on the International Space Station. And Dragon is continuing to approach in closer. It's about 3 meters away, so in 1 meter we will hear that call for CHOP or crew hands-off point.
Freedom 2 meters, hands off.
Copy 2.
And we heard that call for CHOP and just standing by for initial contact and capture.
1 meter.
Freedom, SpaceX on the big loop, soft capture complete.
Copy, good soft capture.
And at 6:25 a.m. Central, 7:25 a.m. Eastern, we have confirmation of initial contact and capture. At that time, the International Space Station and Dragon were flying approximately 260 statute miles over the south part of Brazil. Now that we have that initial contact of Dragon with the International Space Station's space-facing port on the Harmony module, the soft capture system on Dragon will begin to retract to bring the spacecraft in closer for hard capture. So after that soft capture system begins to retract, We will stand by for the hooks to begin driving. Again, there are 12 total hooks.
Freedom SpaceX, ring retraction in progress.
Freedom copies.
So again, there will be 12 hooks that will drive closed to firmly hold Dragon in place, 2 sets of 6 hooks, and then there will be 2 umbilicals that will deploy, and then we will have that hard capture complete. After that, there will be a series of leak checks, and they will begin pressurizing the vestibule, which again is that area between the station hatch and the Dragon hatch, which was previously exposed to the vacuum of space. So once that pressurization is complete, they'll do those leak checks, and then they will begin opening the hatches and bringing Crew-9 back inside the International Space Station, where they will remain until they return to Earth next spring. While we stand by for that hard capture process, let's go ahead and check back in one more time with Shiva and SpaceX.
Thanks a bunch, Anna. It's nice to see Crew-9 on the space-facing port. Of course, we're not fully locked into station yet until the hard capture hooks are securely in place and the vestibule is repressurized, as you were talking about. But as we're in the process of soft capture ring retract, that's getting us on the way to those next major milestones. So part of what the ground station teams are monitoring right now is there's a set of motors on the soft capture system. So those are retracting the system back in. We heard the call out right around the time that we were getting past the 60-meter hold and heading to approach 2. There was a call from the ground to the crew that the soft capture ring had extended. So that was getting it prepared for soft capture, and then now the ring retraction process. Once we get the rings fully retracted, then we start to head into the next major milestone, which, Anna, you were just talking about with the hard capture hooks being connected and the umbilicals that we disconnected earlier on the forward-facing port being reconnected. Those umbilicals are essentially communication and power lines. So they have a series of hard connections. You can imagine plugging in the Dragon spacecraft into the International Space Station. And that's a way that we share data between the spacecraft, the Dragon spacecraft, and the International Space Station, and how Dragon can also keep its power levels high by pulling some data from the International Space Station's power system.
Freedom SpaceX on the big loop, ring retraction complete. Docking sequence is holding for MCS reconfiguration.
Copies.
So the call there indicating that the International Space Station, which was in a slightly different mode for the approach operation and to damp out the loads from Dragon coming and docking onto it, is now transitioning into a more normal flight mode. Once that is complete, Dragon will proceed with its umbilical extension as well as the hard capture hooks. There are 12 of those hooks. They're driven in, they have separate motors on them, and they are driven in sets of 6. And those 12 hooks both secure the Dragon capsule to the International Space Station, but they also make sure that the seals that are on the top of the spacecraft and on the pressurized mating adapter are nice and secure. So once we start putting breathable air into that volume, that we keep that air in there. That'll be referred to as the vestibule pressurization. Once we pressurize the vestibule, ground teams will give a little bit of time to make sure that the vestibule is leak tight before we give the crew the go to doff their suits and then begin the preparation steps for ingress.
Station Houston, big loop. MCS is configured, proceeding with hook driving.
So with that call up on the big loop, ground teams informing all of the crew that ISS is in the correct configuration to begin its for Dragon to begin the hard capture hook drive. Now, the vestibule, we were talking about it a little bit earlier. That's the interstitial volume between the ISS's hatch, the space-facing hatch, and the Dragon forward hatch that had the docking target on it. And that small volume is what we pressurize. It's where the crew will eventually come through from the ISS side to the Dragon side and vice versa. And so when we pressurize that volume, we'll want to make sure that it is leak tight, that we're not losing gas from an imperfect seal. And then once we are confident that that is in a safe configuration, then the crew will be given their go to doff their suits or take off their suits. They wear those primarily as a precaution for certain contingencies. And they also have communication systems built into them, so it makes the operation a little bit easier to stay in communication with each other as well as the ground teams. So the crew will be given the go to take off their spacesuits, transition into some more comfortable clothing, what we're used to seeing them in when we get views into the International Space Station or other events on the space station, and then get back to the rest of their day, which I'm sure is full of additional science and maybe a little bit of rest after the operation. Now, depending on the timing here, the whole process of vestibule leak checks, as well as suit doffing and the other checks that are needed to happen, usually takes about 2 hours for a normal ingress. So depending on that exact timing, the crew will have the option to have some lunch. They actually, as part of their repacking of the capsule, brought in some lunch into the spacecraft. And so they may do that in the capsule if the timing allows. And we are expecting the hatches to come open around 9:05 a.m. Central Time. So far, a pretty clean, normal op. Very fun to see Dragon swap its ports and also to kind of talk a little bit about the spacecraft. Anna, I think I'm going to send it over to you to take us through hard capture complete and the remaining steps to hatch open.
Awesome. Thanks so much, Shiva. It's been great to walk through today's operations with you. Again, they are continuing to work through that hard capture process. So we had the initial contact and capture about 9 minutes ago at 6:25 a.m. Central, 7:25 a.m. Eastern. That first set of 6 hooks has been closed, and that second set of 6, for a total of 12, is currently driving closed. So once we have all 12 hooks closed, we'll have that hard capture that we've been waiting for, and we'll have docking complete. So we're just standing by for the final moments of today's port relocation. And again, once we have that hard capture, the crew will begin working through the hatch opening operations, which includes repressurizing the vestibule, which is that area between the Dragon and space station hatches that were previously exposed to the vacuum of space.
Freedom, SpaceX, Big Loop, hard capture complete.
Copy, hard capture complete.
And we just heard the call up to the crew from teams here on the ground confirming that we have hard capture complete. So all 12 of those hooks have closed, and it has formed that tight seal between Dragon and the International Space Station, which completes today's port relocation operations.